Greetings, my little triglets. Today we need to finish section 6.3. We'll call it 6.3b since it's the second part. Today we're going to talk about half angle formulas. Before we talked about double angle. Half angle formulas are used in calculus a lot. And again, it's using an angle, cutting it in half to be able to use it with an angle that we do know if we don't know the other angle. These you do not memorize. These I will give you on any test that we have, so don't worry about these and memorizing them. Okay, the first one is sine of a over 2. That shows that it's half of the angle that we're looking for. And the formula is plus or minus 1 minus cosine a all over 2. Cosine of a over 2, it's very similar. Instead of minus, though, it's 1 plus cosine a over 2. Now, there are 3 tangent ones. So I'm going to go to the next page and do the tangent ones. Tangent of a over 2 is plus or minus 1 minus cosine a over 1 plus cosine a. Now this is a combination of the sine and cosine ones. The 2's have just been canceled out. So if you know sine and cosine, you can get the tangent one. However, there are 2 other ones that are probably a little more useful. Whoops. Let's do that again. Tangent of a over 2 equals 1 minus cosine a over sine a. Now that one's nicer because it doesn't have any square roots. The second one of this type is sine a over 1 plus cosine a. Now for me, my favorite one out of all 3 is this middle one because it doesn't have a square root and it doesn't, oops, I don't know how to spell, doesn't have a plus in the denominator, because if you have a plus like this one does, you might have to use the conjugate to get rid of it. So that's not very fun. All right, so now that we have these all written down, let's do a few problems involving them. All right, if you are given that tangent of A is 5/12 and sine of A is less than 0, which means it's negative, I want to find the exact, remember when it says exact, you're supposed to put your calculator away, of first of all sine of A over 2 and then cosine of a over 2 and tangent of a over 2. We're going to find all 3 of them. So sine of a over 2, the formula is plus or minus 1 minus cosine a over 2. Now they don't give us cosine of a, but they give us tangent of a, and then they tell us that the sine of a is negative. So tangent of a is positive over here. So tangent is positive in the first and third, but sine is negative in the third. So we have to be in the third quadrant. So that's where we draw our triangle. Every time they talk about quadrants, you just draw the triangle in there. Now let's plug in. Tangent, remember, is y over x. So y is 5, x is 12. Because we're in the third quadrant, those are both negative. And this is a 5, 12, 13 triangle, so you can plug that in too. All right, so now putting in for cosine, the cosine of A, remember this is triangle A, so the cosine is negative 12 over 13, x over r. So 1 minus negative 12 over 13 over 2. Now we're going to need to simplify this. I think I'm going to put everything with 13s on the bottom. So I get this 1 is going to turn into 13 thirteenths. And I already have, now this minus and this minus is going to be a plus, so 12 thirteenths. And 2 turns into 26 thirteenths. Let's make that a little bigger. Now all the 13s can cancel, and I'm left with square root of 25 over 26. And mentioned, you can't leave it like that. The 25 can come out as a 5, and then get the radical out of the bottom. You're left with 5 root 26 over 26. Now, we have to figure out this plus or minus thing. Which one is it? This is where a little confusion comes in. Now, this triangle that we drew right here is angle A. I am looking for A over 2. So if A is in quadrant 3, where would A over 2 be? Well, we can test this out. Let's pick an angle in quadrant 3. So I'm just going to say this is at about 200. Okay, if A is 200, A over 2 would be 100, and that would be in this quadrant. Okay, so it's in the second quadrant, and because we're looking for sine in quadrant 2, that would be positive. So this answer down here is positive, 5 root 26 over 26. So you go with where A is, and then you cut it in half. And any angle in here, if I pick, 185, that's going to be right here. It's always going to end up in the second quadrant. If you're cutting quadrant 3 angles in half, they'll go into the second. All right, so this is our answer for this problem, sine of A over 2. Let's do the next one. Let's go to the next page. Cosine of A over 2. I'm going to redraw that triangle, same thing. And it was -5 here, -12 and 13. So that's angle A. So cosine of A over 2 is 1 plus cosine under the radical. Cosine of A over 2. And it is plus or minus. But we already said that A over 2 is in the second quadrant. Cosine is negative in the second quadrant. So I know my answer is going to come up negative. All right, putting in the cosine is -12/13 over 2. Let's change everything to 26s again. I'm sorry, 13s again. So I have negative 13 over 13 minus 12 over 13 over 26 over 13. Cancel the 13s. I'm left with square root of 1 over 26. Bring out the square root of 1. Get rid of the 26 on the bottom and make sure you keep bringing that negative along with it. So negative root 26 over 26. Now tangent of A over 2 is just sine of A over 2 over cosine of A over 2. And we already did both of those. So rather than putting it in a formula, we can just put the answer to the sine, which we said was, let's go back there, 5 root 26 over 26. And then the cosine, which we just did, was negative root 26 over 26. This part cancels, and we're left with just -5. Okay, so if you didn't use that, then you can use one of the 3 formulas and just plug that in. All right, now let's do another one. I want to find the cosine of 5 pi over 12 using the half angle formulas or double angle formulas. Now, it doesn't say which one, but only one of them will work. And you have to test it out. If you're going to test to see if the half angle formula is going to work, what you do is you take half of the angle and set it equal to 5 pi over 12. Then we have to solve for A to see if it's on the circle. And if it is, then we can use the half angle formula. So right now, I'm going to multiply both sides by 2 to get that alone. So I get 10 pi over 12, which is 5 pi over 6. Is that on our circle? It so most certainly is. So we will be using half angle. Now let's just do the double just to see what it looks like. So I would say 2a equals 5 pi over 12. Again, I'm going to divide both sides by 2 Cancel those, so a equals 5 pi over 24. That's not on our circle, so we know that we have to use the half angle formula there. So then you do it just like we did the other one. You put this in for a into the formula and go from there. All right, so we also have some kind of Triggy proofs that you're going to need to know how to do. And let's do one starting off with using the formulas that we've learned. Sine of 2 theta over 2 sine squared theta. I want to prove that reduces down to cotangent of theta. Now you have to look at these and decide what formulas you have. This looks like a double angle formula. Sine of 2 theta has another form. It's 2 sine theta cosine theta. That's its other form. Put that in, 2 sine squared. I don't really want to change anything there. If I did, this would be Pythagorean. It would be 1 minus cosine squared, but that doesn't get us closer to our goal over here. So right now I can cancel the 2's. I can cancel one sine with another sine, and I'm left with cosine over sine, which is cotangent. So that's exactly what we wanted. All right, let's try another one, another proof. Let's prove that the cosine of A is equal to cosine squared A over 2 minus sine squared of A over 2. Now these right away look like half angle formulas, so that's going to be our starting point. We're going to look at the half angle formulas and we're going to square them. These tell us to square those half angle formulas. For cosine, it's plus or minus 1 plus cosine A over 2, and then minus, and then don't forget the square, and then minus, plus or minus 1 minus cosine A over 2. And again, I have to square that. Now, squaring a plus or a minus is going to end up being positive. Squaring a square root leaves you just what is underneath. So what I end up here with is this. Now, why did I put that second one in parentheses? Well, because this minus sign means everything in that parentheses gets subtracted. Now, because I have a common denominator, I can just make a 2 on the bottom and then write out the numerator, 1 plus cosine A. Then I have minus 1, and then minus and a minus would be plus cosine. All right, so now look at what we can do. We can get rid of the 1's, and I have 2 of the cosines, so 2 cosine A over 2. Cross off the 2's, and I've got just cosine left over. Okay, so work on the more complicated side when you do these proofs, and look for the formulas that we've been doing all along, the half angles, the doubles, anything sum and difference wise also. Okay, that's it for this section. Ta-ta for now.